So this is your first day with us. That's right, Jolisa?
Yes. Yes.
Okay, so you only have math left, right?
Yes.
What are some of the things that you're struggling with in math?
I would say the dividing of fractions and stuff like that.
So you feel
And
pretty good about a lot of the other things? Is that what you're like? If you were to take the GED tomorrow, what would you think? Well, those are the things that would challenge you the most would be the fractions, you think?
That and this, what you have on your screen, like the x2, subtract the 5x plus 6.
Okay. All right. And how much have you done with what's on the screen, like the polynomials? Have you worked with them before? Polynomials and quadratics, or no?
A little.
Okay, just a little? Okay. All right. So maybe it would be helpful if we kind of went over kind of what polynomials are first, and then you can kind of let me know what you remember and what you don't. And then we can kind of just base the class on that. Does that sound good?
Yes.
Okay, great. Let me try to pull that up right now. Okay. Let's look a couple things first. Perfect. Okay. So let's just take a look at what a polynomial is before we even get into these questions on the screen. Let's just really talk about polynomials. So did you find this class on in your Schoology? Were you able to go into the GED prep for math and science? Were you able to find that course in Schoology?
Yes.
Okay. So this is the course here in Schoology. And what we're going to work out of today is this green folder, expressions, equations, and inequalities.
Okay.
And I'm going to start us here in lesson 5 with the introduction to polynomials. Okay. So we're going to go over these notes on what a polynomial is and how to identify them. And if you feel comfortable with that, you're good with that, or you want to do more practice with that, we can kind of leave it there. But if you want to continue, we can then continue on with quadratics after. Okay. So we'll.
And I have a question.
Go ahead.
I also have issues. You know how they have like, is that exponents with the graph where you have to point what the x is or something?
So yeah, so quadratics, there's a couple different ways to solve quadratics. Sometimes you use a graph, sometimes you don't have to use the graph to solve them. But yeah, there's one of the ways is to use the graph to kind of figure out what the x values are.
Okay.
Yeah. So the quadratics are always the graph with that make the U shape.
Yeah.
That's the quadratic, yeah. Okay, let's start here with these polynomials notes. I'm gonna open that up with Cami so that we can make our edits right on there.
Okay, can I use one of your pencils?
I'm sorry?
I'm just grabbing a pencil.
Oh, okay, got you. Okay. All right, so I'm just going to kind of go over quickly what a polynomial is and kind of the example, go through these examples here, but we can see down here that these are examples of polynomials, right? So what do you see? What do you see in these examples? Can you identify these things that are here in this polynomial? Like the 2, the x, the a, what do you see?
2 plus x and 5a
Okay,
subtract 6ab.
okay, and
That's
what is the 2? What would you call that 2? What's the term that you would use to describe it?
I have no idea.
What about the x? What's the term that you would use to describe that?
I don't know.
Okay. All right. So those terms, we gotta make sure we gotta identify what these terms are, because that's going to help us set up our complete and total understanding for all polynomials and how they work, especially when looking at the GED, because they like to reference these words. And so these words are important. I'm sure you've seen them before, but it's important to have a definition of what those words are, just so that you don't miss a question that's relatively easy because you just didn't know what word they were talking about.
Gotcha.
All right. So when we're looking at something like the 2 or the x, a 2, when it's part of a polynomial, when it's part of a system that looks like this, the 2 is known as the constant, right? So any number that does not have a variable with it is a constant, right? So any letter.
So would a variable be what, 3y?
So that's not, so that would be a variable, it would be a term that has a variable in it, right? So 3y, like right down here, what you see is it is a term with a coefficient and a variable, and we're going to get to that in a second. So let me just write down this variable right here. This is a variable, right? X is a variable.
Gotcha.
And a term, or so this, when we combine the constant with the variable, right? We have a coefficient with a variable. This is what we're looking at here. All right. So 3y would be a coefficient with a variable. So now when a number that's no longer by itself but becomes attached to a variable, that number goes from being a constant to being called a coefficient, right?
Gotcha.
But the variable stays a variable, okay? So it's just a coefficient with a variable. And so that means that anything that you see in a polynomial, every separate thing that's separated by either a plus sign or a minus sign is considered a term. So when I have 2 plus x, I have 2 terms. One is the 2 and the other one is the x. Okay, those are both individual terms. And when I have 5a minus 6b plus 3b to the 4th power, how many terms do I have there?
3.
Yeah, you have 3 terms. Good. Anytime you have a separation with a minus or a plus, that is a term. But when you have multiplication and division, they're considered together. They're linked together. They're not separate, right? But they are separate when you have plus or minus.
Gotcha.
Okay. So those are terms and those are examples of polynomials. So kind of to summarize that idea, a polynomial can have constants, variables, and exponents, right? You can have addition, subtraction, and multiplication, and you can also have division by a number. All of those things are things that you can see in a polynomial. What you're not going to see in a polynomial is division by a variable. You're not going to see negative exponents or decimal exponents or just an impossible number of terms. It just keeps going and going and going and going. When you can see all of these things in math in general, but you're not going to see it in a polynomial, all right? When you see these other things, they're going to be separate. They're going to be by themselves. They're going to be part of like another topic. But when we're talking about polynomials, these are the things you're going to see on the left, and here's what you're not going to see on the right.
Okay, but what is the difference from the y over, the 2, y over 2, well, y over 2 and the 5 over x? What's the difference?
Right. So what's doing the division in this one?
The 2.
Good. What's doing the division here?
It would be x.
Yeah. So that's the difference. It's because I don't know what's doing the division. Is that's why you can't have it, right? Because that x can be any number, and you can't actually have division by 0, for instance, right? So that's why it's impossible to have division by a variable. Okay, in a polynomial. Good. That's a good question. Shows that you're paying attention. Very good. Okay. Let's kind of keep scrolling down. All right, so our polynomials, right, are named based on the number of terms that they have. So if they only have one term, they are called a monomial. If they have two terms, they're called a binomial, just like a bicycle, right, has two wheels. So it's a binomial. And a tricycle has three wheels, so it's a trinomial if it has three terms, okay? Once you get over four terms, there's no special name for it, okay? But these one terms, two terms, and three terms have special names. So when you have one term, it's called a monomial. Two terms, it's a binomial. Three terms is a trinomial, right? That's the first level of naming. But there's a second level of naming as well. They're named based on the power or the exponent that you see in the polynomial, right? So here we don't have any exponents in this first one. The 6x, there's no exponents. But here we have 3x squared. Once you have a square as your highest exponent, it has a different name versus one that has a cubed as a different exponent. So let me go down and you'll see how to name them there, okay? So we also have degrees of polynomials, right? And that's how when you define it by the exponent. This polynomial has a degree of 4 because the largest exponent is 4, right? In that single term. In really complex polynomials, they might have more than one exponent in a term, and then you have to add the exponents together to get the actual degree. So 4 plus 2 gives me 6, 3 plus 5 gives me 8. This is actually the biggest term, and so this is a polynomial with a degree of 8. All right. So the naming becomes complicated when we think about both of these things. So there's also a chart to think about the degree. We only count the degrees up to a certain point, and then after that, we don't care. We just say the 8th degree. We don't have a special name, but some of them do have a special name. And so we're going to talk a little bit about that as well. But again, the degree is the largest exponent found in the polynomial. Okay. And why that's important is because when you write your answers in standard form, you have to put the term with the largest exponent first, okay? And then the smallest exponent last. Okay. So standard form means you have to arrange the order from the biggest to the smallest exponent. Okay. I'm throwing a lot at you, so always feel free to stop me. You're lucky you're the only one in class. You have all of my attention. So anytime you need to stop me, just stop me. All right. The leading coefficient is the coefficient of the highest term, right? So we'll see an example right down here. So this one is written in standard form. So it has x cubed first, but of course there's a 2 in front of that x cubed. That's the coefficient of the first term. So that is what is considered the leading coefficient. Okay. Okay. All right. And again, a constant is a term that has no variable. So it's just a number. Not every polynomial is going to have a constant. Not every polynomial needs a constant. But when it's there, when it's just a number hanging out by itself, it should appear at the end of your standard form, right? And it is considered a constant. Okay. Okay. All right. We just learned a lot. So let's try to synthesize it and make it make sense by doing a couple examples. So we see the example here. It's not written in standard form. It's 4 minus x plus 2x cubed. So we have to find the degree by finding the highest exponent, which we did. The highest exponent is 3. So that's the degree of that polynomial is 3. When we put it in standard form, we put that term first, followed by the next highest exponent, which would be the exponent of 1, right? We have a variable, and anytime we see a variable without an exponent, that exponent that is there must be 1, right? We don't have to write it, but
so x will be 1.
The exponent on that variable is 1. Right? We
Okay.
don't have to see it, but we have to understand that whenever we have a variable by itself, it has an exponent of 1 just hanging out with it. Okay?
Okay.
We're never going to see it, but we just have to understand that it's there.
Okay.
All right?
Always, right?
Anytime a variable is hanging out by itself, it always has an exponent of 1. We're never going to see it, but it always does.
Okay.
Okay? It's actually the same for any number as well. Every number also has an exponent of 1, but we're only counting the exponents on variables when we're looking at polynomials, right? Okay. We only care about the exponents on variables. All right. So this 4, because it doesn't have an exponent, right? There's no, because it doesn't have a variable, right? Its degree is considered 0, right? Because there's no variable, so its degree is 0. So 3, 1, 0 is the degrees that we have visible here. And that's what we're working with. I'm just going to put that in as an example. Sorry. This has an exponent of 0. A degree, I'm sorry, of 0. All right. I'll take those out later because we don't actually need them, but just so you can see it. All right. Again, the leading coefficient is 2. Our constant is 4. We have 3 terms, 1, 2, 3. So we call it a trinomial. All right. Now let's look at this next example. A little bit more complicated. There's a lot going on here. But what exponent is the highest? 2, 3, or 6?
6 is the degree.
6, right? So that is my degree, right? That's how I mark the degree, by finding the highest exponent. And so now I'm going to put it in standard form by making sure that I put that term that includes that exponent first. So I have 3x to the 6th power, right? And what's tricky here is that there is a negative in front of that 3x to the 6th power. So I have to carry that with it. So it's going to become negative 3x to the 6th power is what I'm going to write first. And then I have to put the next term. So the next highest exponent comes next. The next highest exponent is going to be that 3, right? So I have to do plus 4x to the 3rd power. And I have to do the next highest exponent, which would be
Plus x to
the
the
x squared.
And then plus 2.
And finally, I'm going to end with my constant, which is 2. All right. Is that good?
Yes.
All right.
So would the leading coefficient be 3, a negative 3?
Yes, good. Make sure you carry over the negative, but yes, negative 3. And what's my constant going to be?
2.
Perfect.
And it's just when it's more than 3 is
just a polynomial.
Yeah.
Okay, perfect. All right, do you need to do that again, or do you think you got it?
What do you want? Do that one.
Yeah, let's do the next one. Okay, great. So what's the degree on this one going to be?
1.
Perfect. Okay, so then I'm going to write what first?
Would that be a negative 5?
Mm-hmm. Negative 5x, and then I just put my 3 next. Okay.
So how will we know? So automatically it will be a plus because that's a negative?
Right. No, because there's no sign in front of the 3, so that means it must be positive, right?
Okay.
If we see no sign or we see a plus sign, we're going to assume that it's positive.
Okay.
Right? When we do see a sign that indicates that it's negative, that means we're going to keep it negative.
Okay.
Or a minus sign is going to make that whole term negative.
Okay.
Mommy, my teacher needs you.
Okay, I'm in class. Ask her what she needs. Okay. that will be a -5.
Good.
And then 3, and it's a binomial.
Perfect.
I don't need you no more. Okay.
Excellent. All right.
So, okay, wait. This, I think I figured out the next one, but 14.
Okay.
That would just be 0.
Mm-hmm.
And 14, right?
Of course. Yep. Again, 14.
14. And it's just
14. Actually, our leading coefficient, right? We don't have a coefficient, right? Because there's no variable.
okay.
So again, it would be 0. Our variable here, though, our constant, I'm sorry, would be 14. And then we only have one term.
That's a monomial.
Yep.
Okay. I kind of got it.
Okay. So let's get into naming these degrees. I'm pretty sure my next slide is that. Yes, perfect. So when we are naming our degrees based on the exponent, when we don't have an exponent, when it's 0, of course, we just keep the same name that we were using before. It's a constant, so it just stays a constant, right? When we have a degree of 1, that is considered linear, right? Like when you make a line, you just have y equals x. There's no exponents on there. It's just a linear polynomial. The next thing is when you have 2, when you have your squares, right? This is what we call the quadratics.
Okay.
All right. 3, exponent of 3 are there. Those are the cubic functions. 4 is the quartic functions. Excuse me, it's with a Q. Quartic functions. And 5 are the quintic functions. We thankfully do not have to do a lot of work with quartics and quintics on the actual GED other than like reducing them, making them smaller through division. We don't have to do any graphing of them or anything like that. But quartics and quintics are the highest degrees that you should know the name of because they might be mentioned. After that, we just call them by their degree, right? So we just say 6th degree polynomial, 7th degree polynomial, et cetera, et cetera.
Okay.
Right, but constant is the ones that are just the constants. Linear have an exponent of 1, quadratics exponent of 2, cubics exponent of 3, and then quartics and quintics 4 and 5. All right, so those are how we name them. All right, what do you remember or what do you know about adding polynomials? How do we add them? What do we need to know about them in order to add them?
I have no idea.
All right.
What we just learned?
So it's kind of based on what we just learned. Yeah. So what would I have to be able to do?
You got to put them in order first, right?
There it is. Yeah. You have to put them in order first, and you can only add the ones that have the same degree. Okay. Like I can't add 6x minus 1. Like I can't take that 1 from that 6, right? They're two different things altogether. So put them in order first and then only combine the ones that have the same degree. All right, so when I rewrite this in order, I'm going to do 6x to the 4th power.
Class. I love those. Okay. Then it'll be 2. Is that plus 2?
6x to the 4th power, and then we're going to do the next one would be the 2x cubed. And the 3x to the 2nd power. Minus 5x minus 1. And we're adding it to negative 2x
2x
to the fourth. Yeah.
then
X cubed, right? Yeah, what's next? X cubed.
then 5
Plus 5x squared. Oops, sorry. Plus 5x squared.
And that subtract 6x.
Good. Well, so we have a couple actually that have the same degree here. So we have minus 7x
Oh, well,
minus
7x.
6x. So we should probably do both of them and just combine them together, right? So what is negative 7x minus 6x? Let's just combine it into one term to make it easier for us. It's still going to be subtraction, but if I already have a negative 7x and I'm taking away another 6, now I have
That is
negative
wrong.
13, right?
Hold on. You say a negative x
Negative
subtract.
7x minus
So a negative.
another 6x.
Oh yeah, you gotta go up. Negative. Okay, I got you.
Yep, okay, good. So it's negative 13x. And then the last thing is this 5 plus 5. Okay, so since I'm just adding them, right, all I need to do is look at the two terms that have the same degree. So I'm going to do 6 plus negative 2, which would just be 6 minus 2. What's 6 minus 2? 4,
Hold on.
right?
You say 6x
To the fourth power.
then negative 2x
Minus 2x to the fourth power.
because they have the same components.
Because they have the same degree, I can only combine them, right?
Okay.
So that's where I'll start. So 6 minus 2 will give me 4, right? And I just bring down the x to the fourth.
Okay.
Perfect. Now I got to combine the x cubed. So what would I get when I combine these two? I have 2x cubed.
2x to the 6.
So I don't add by exponents, right? I'm only going to add my coefficients, all right? So that's the rule about adding these polynomials. When I add them, just like what I did with the 6 and the 2, I just did 6 minus 2 to get 4, but I keep the exponent. So it's just x to the fourth. I'm not going to change my exponent, so I don't combine the exponents at all, right? So essentially what's happening is I'm saying on the left, I have 6 apples, and on the right, I need to take away 2 apples. 6 minus 2 still leaves me with 4 apples. I haven't changed the kind of apples that I have or anything, right?
Okay.
I'm just combining the terms. That's what we call combining like terms.
Gotcha. So it should be 2 plus 3. I mean
2 plus 1 to give me 3. Yep. Good. 2 plus 1, which gives me 3. So I have 3x cubed. And now I have 3x squared plus 5x squared. How many x squared? Yep, I have 8x squared.
X squared.
Perfect. All right. Next, I have negative 5 and negative 13. Combine them together, I get
3x.
So I already have a negative 5, and I'm making it more negative. I'm just adding more negatives to it, so I can just add them together. Good. I just add them together and keep it negative. So I have negative 18x. Good. And then the last one, I have minus 1 plus 5. It's going to give me how many?
4.
Perfect. That is it.
So that would be your answer?
That's my answer.
That's a lot of work just to get that answer.
Yeah, that's the biggest issue with some of these GED questions, right? It takes a lot of time to organize an answer. But yes, this is the answer.
Okay.
All right. And adding is the easier part, because the harder part for me is the subtraction. So we're going to try this addition for this one right here. And then we're going to look at how to do the subtraction, and we're going to come back and kind of compare. All right. So again, what we can do, you can either do it in your head, if it works easier for you to do it that way, or what I always suggest is what we did before, right? Just write it all out. But combine your like terms first that you have on each side. So both of these are x cubed, right? So I need to combine these two together first. I have negative x cubed and negative 2x cubed. When I put it together, how many do I have?
6.
So not the cubes. I'm only going to put together what's in front of the...
It's negative 3.
Perfect. That's it. It's all right. You're going to get used to it. You can't expect on the very first time to always get it right, but that's what we're doing. Yes. Okay, and then next we only have one x squared, so I'm just going to put it in there, negative x squared. Oop. Need my superscript. All right. And again, I only have one x, so I'll just put the plus x. And then I only have one constant, so I'll do plus 8. All right, so that's everything I have on the left. And I have to add it to what I have on the right. And on the right, it's already in order. So I don't have to make any changes. Right? I can just go ahead and do my answer. I have to combine the negative 3 with the 4. I'm going to be left with how many?
7.
Negative 3 and 4. I have a negative on this side, but I have positive on this side. I'm going to end up with
1x.
Right? And I never have to write a 1.
Oh, you don't have to put the 1?
Correct. Yeah, whenever I always have to assume that whenever I see a variable, there's a 1 in front of it.
Okay. And
okay, so now I have negative 1 plus negative 1. That's going to give me negative 2, right? Negative 1 and negative 1, they're both negatives, so I have to combine them. I get 2. Negative 2x squared.
why did you take that plus from?
What plus?
Remember you was about to put x 1x3 plus.
So right here we have a negative, but we're adding another negative.
Okay.
So when we add two negatives together, we're just combining them to make them bigger negatives.
Mm-hmm.
So that's why I have negative 2.
Okay.
Good question, though.
Plus.
Okay, and now we can add the x's. I have 1 x here and 8 x's here.
So that's 9.
Good. And now the constant. I have 8 and I have a negative 3.
5.
Good. Perfect. So that's my answer for that one.
Okay.
X cubed minus 2x squared plus 9x plus 5. All right. Sometimes it's good to organize them vertically like this to try to add them. This actually might work better than doing it horizontally. If you're, I think for me, putting it vertical actually makes a lot more sense. So always remember that you could just line them up, right? Just like you would do a normal or like the original
Right.
addition and subtraction, just put it just like that to make it easier for yourself. All right. When we are subtracting, though, one of the things we have to remember is we have to apply this negative. We have to distribute it to everything inside the parentheses on the other side of the negative, of the minus sign. So instead of a positive 5x squared, we have a negative 5x squared. instead of a negative 7x, we have a positive 7x because a negative times a negative gives me a positive.
Mm.
And then same thing here with this positive 6. When it comes out of the parentheses, it becomes a negative 6. So then when I end up combining everything together, it's 2x squared minus 5x squared, which gives me negative 3x squared. Negative x squared plus 7x just gives me x.
Mm.
And then 5 minus 6 gives me negative 1.
Okay.
All right. So subtracting.
So anytime when it's 1, you don't have to put 1. You just put the x.
Correct. Anytime you have a variable or a variable raised to any power and it's just one of them left, you do not put the 1 in front of it. Correct. You're just going to put the variable.
Gotcha.
All right. So let's try this one. I'm actually going to use my.
They're in order already.
Good. Yes, exactly. They are in order already because we're going to set them up
Vertically.
I'm going to use my pen for this. I'm going to plug it in. Give me a second. All right, so I'm going to apply my negatives. That means I'm going to change the sign for everything to the opposite. This is going to be a positive. This is going to be a negative. This is going to be a positive. This is going to be a negative. And I'm going to line it up under. So I have minus 2x. Nope, sorry. It's going to be a plus.
To the third.
This is going to be a minus 4x squared.
Square.
It's going to be a plus 5x. This is going to be minus 3. Okay. All right. So 7 plus 2 gives me 9. Negative 2 minus another 4 is just going to give me negative 6.
6x squared.
I have negative 3 plus 5. So that's going to give me 2. And then negative 10, I'm taking away 3 more, gives me negative 13.
That wasn't so hard.
Right. So with this additional step, the biggest issue really is making sure you do that and then lining things up vertically. Vertically is going to be the easiest way to solve these problems, but they're always going to give it to you horizontally, right? So I like to do it that way first to show people how challenging it is to have to think about it in those terms. And then when I see that you can line it up vertically, like, oh, I will do this from now on. I'm like, great. Because you have to go through that process or else you won't see the struggle. And then you'll sit there on the test, doing it horizontally. You're like, oh, let me match this. Okay. And then match. Okay.
So when there's a negative, when you're subtracting, you should change the signs on the right.
For each individual on the right, for each individual term. And also make sure you do that first before you try to set it up. If you do it afterwards, you're gonna have too many scratch outs like I do over here. Like just line it up under here with the correct sign already. That's going to be very helpful to you.
Gotcha.
Okay. All right. So you've seen a lot about these polynomials. What do you want to keep working on something? Do you want to advance to something else? Do you have more questions? Like there are a lot of things, and I'll just go back to our page real quick before you answer that question, just so you know.
There'll be, in Schoolology, there'll be a couple of more that I could do over.
Correct.
Well, I can always go back and open it up in Candy.
Yes, exactly. Yeah. And I just wanted to show you in general. Yeah, so there's a couple practices here for adding and subtracting and identifying polynomials. There's also like an exit ticket, extra practice on there. And if you just in general kind of explore the Schoology course, there's a lot of different topics that I've already tried to include in here of like things you can go and practice.
Okay.
But I also want to make sure that like I'm, setting up classes that work for you and like whatever you're currently struggling with so that I can make it easier for you to kind of get over that and be ready to test, right? Like, especially because you only have math left. I want to make sure that you're not here for 2 years trying to become perfect at math to feel comfortable with passing the test. I want you to feel comfortable sooner than that, so that you can just take the test and do what you need to do, and then move on to whatever else is next for you.
Okay.
So so just work with me and let me know what it is you're struggling with, so I can actually like prepare ahead of time. Like, here's what the class is going to look like. Here's what we're going to kind of go over. But yeah, but go ahead and let me know, what are you thinking right now when it comes to these polynomials?
Graphing and slopes.
Okay.
I know I need to work on that too.
Okay. All right. All right, let me pull up some of the things that we already have. All right, so these notes are really just a good summary of where to kind of begin with graphing. It gives you all the levels, right? So depending on how you're coming in, what you need reminders of, it goes from the very basics.
How do you read the graphs?
Perfect. Yeah, it starts even right there. Yeah, so here is,
because I remember this on the test and I was just like, I know how like the points of it, but I just don't know which point you put first. Like, do you
good.
put your negative first or do you put your positive first? I was
Yeah, it's always the X first and then the Y, right?
Gotcha.
And so you're always gonna start moving left to right if you're given a point to graph, for instance, right? And the points are always gonna look like this, right? If they give you a point, they're more than likely gonna put the point into this situation, right? They're gonna do something like this, right? They're gonna have the number separated by a comma. This first number is always the X and the second number is always the Y.
Gotcha.
And so you go to the right first, because if it's a positive number, you know you have to move to the right from the middle. So you count over by 7. You don't put the point there though. You go to the other part of your address, right? Because this is an address essentially. And now you go down by 4, 1, 2, 3, 4, and that's where you put your point. Okay?
That's 5 you put it at.
Oh, did I? I did. I counted too fast. That's me moving too quickly.
Let me go to
But yeah, so you put your,
and I know I got that answer question wrong for sure.
yeah.
I went from left to right.
Yeah, so that's how you do it. So think of this as directions on how to get to a certain address, right? So this is the whole address in general, right? But you have to look at each part as the directions, right? So like, oh, you're gonna go down this street for 7 blocks, right? And then you're gonna turn and go 4 more blocks, right?
Yeah, because to how on a test I went, if it was 7 then the -4, I went up 7 and then over to the negative. So I know I got
right. Yeah.
Instead of going.
So always go left or right first, and then up or down, right? The problem with that, and like it sounds really easy, especially like as I'm saying it to you right now, you're like, oh great, I'll remember that. The problem is that it gets confusing because when you look at your slope, it's the other way, right? For your slope, you move up or down first, then left or right.
What you mean slope?
So for instance, right, if I tell you, oh, that's your first point, but I want you to graph a line that has a slope of 3, right? So it'll give you the point, and then it's like, so put your point there, and then graph a line that has a slope of 3. And I'll say like your m is equal to 3, because m is the letter that we use for slope, right? And so what that means is that from this point that I've graphed, I need to go up by 3, 1, 2, 3, and over by 1, and make another point. And now that I have those 2 points, I'm going to connect them together with a line that goes through them. And now I've created a line that has a slope of 3, and it goes through that point.
Okay.
Okay. So those are some of the things that it'll ask you to do. It'll give you a point and then tell you to draw a line with a slope of 3, and that's what it's looking for. But how you calculate your slope is that it's rise over run, right? So you have to go up or down first, and then left or right.
Gotcha.
And so what I did was I went up by 3, 1, 2, 3, and then to the right by 1 to make my next point. And if I drew my graph correctly, right, I should be able to keep doing that, right? Go up by 3, 1, 2, 3, and go over by 1, and this is where the next point in my graph should be. I wasn't really drawing my graph well, but let's undo it. Let's do it properly.
But I can see where the points are meeting up to.
Right. So again, I'll just start off where I was supposed to start off. 7, negative 4, 1, 2, 3, 1, 1, 2, 3, 1. And then if I go in and actually make a real line using my drawing tool here, I can connect them with a real line. And it'll work the other way as well. So now if I go back in just to test and I go down 3, 1, 2, 3, and to the left by 1, it makes it onto the line. Yay, it worked. Okay, so that's the kind of the idea here. But the other thing you have to be able to read on this graph is, so where did you make that first point? You made it at 7, negative 4. What quadrant is it in? And you need to know that it's in quadrant 4. Well, how do we count the quadrants? Well, we start here on the upper left. This is 1. You go to the left, that's 2. Under that is 3, and here is 4. So they might ask you the location of that point, and you need to know that that's quadrant 4 is the bottom right. The top right is quadrant 1. The top left is 2. Bottom left is 3, right? So you start here, 1, 2, 3, 4. That's the order of the quadrants. And I was not trying to draw that, but it happened anyway. Okay, so yeah, so these notes cover a lot of that information, how to graph, that the X and the Y is how you're moving, X coordinate, Y coordinate. Gives you some information about the plane, and also kind of tests your ability to do those things. And what's great about a lot of the stuff in these folders as well is that some of it has already been covered by me. So I can give you a whole class on it, or I'll give you a class on whatever you request a class on, but some of it might already have a video of me going over the notes already in there. So you can even take your own time to kind of like teach yourself something. You don't need to even rely on me. But yeah, so there are things in there already. But here in the graphing and slopes, to kind of stick with that, that recording is in here as well of me going over those notes.
Okay.
All right, so there is additional help there if you want to try. And of course, there's some practices on how to do the coordinate plane. A reminder of how to find your slope, because there are 4 different ways to find the slope. So I've put that in here just as a reminder of how to do it. Do you remember the slope formula? No, because this is the first time you're learning about slope, right? Because you asked me what slope was. All right, slope is, let's see if I have some more notes in here. Please tell me I do. Slope is a super essential part of this, actually. I don't.
Go back down where it was like y equals 1 something. Yeah.
1/2 x, yeah.
Yeah. How would you solve that?
So this is an example of where, and I'm going to get some better notes in here for you so you can see this, but this is the standard equation for a line, okay? Y equals mx plus b. Your m, again, is your slope, okay? And your b is going to be your y-intercept. So given this equation and understanding what m and b are, can you tell me what the y-intercept is for this line and what the slope is?
No, I can't.
Okay.
I'm lost.
So my slope is my m, right? Where does my m always show up? Right before the x. So what's right before the x in this line? What number?
It's a half number though.
1/2, right? Yeah, so that's my slope.
Okay. Oh.
What's my y-intercept? My y-intercept always appears after the x. Is there anything after the x here?
Nope.
So my y-intercept is 0. Okay? So this m and this b here, these are not real variables. They're just placeholders for numbers that will always appear in this equation, right? So the number that appears right before the x, or the coefficient of the x in any line, is the slope. And the number that appears after the x as a constant is your y-intercept. So that means I can use that information to graph this line, right? The other thing I can do, I'm very lucky that there's already a table here. So I don't even have to know this to be able to graph this line. I just have to follow these addresses that were given to me, right? So 0, 0 is right here in the middle. That's my first point. Where's my next point?
1, 2. Well, 1.
What do I do?
Go over 1.
Okay.
And then go up 2.
Perfect. That's my next point, right? And then I can do that for the next point, and then I just connect them together to make that line, right? So all I want you to do in this case is to graph it. When you're asked to graph, if you're given a table, you're done, right? You just follow the instructions in the table to make your line. If you're not given a table, you can figure out how to begin by using the y-intercept and the slope. So
how will you do that without that graph though? How would you?
So my y-intercept is 0, right? So that means I know that my first point is at 0, 0. That's what that tells me. When I know what my y-intercept is, that's where I start. Okay. Now, where do I make my next point? I have to make my next point according to my slope. My slope tells me to go up by 1.
Okay. And over 2.
And then over by 2. This table is not for this graph. Yeah, this table is not for this graph. This is incorrect. All right, up by 1, over by 2. Up by 1, over by 2. Up by 1, over by 2. I make my points and I connect the line. Yeah, this table is
now. What if that was like 3/4? You can still do that from there.
Exactly. You do the same thing. You go up by 3.
Over and then okay. It's not as
3,
hard as I thought it was.
Over by 4. No. Yeah, you just have to know it, right? If you don't know it, right? A lot of the things on the GED is about definitions and exposure, right? Don't get me wrong. There's a lot of tough math on the GED, but some of it is really just about, did you get the definition of what this means, right? Like, did you learn this thing? Because if you learn this thing, it's 2 seconds, right? But if you never learn this thing, you're like, I don't know what I'm supposed to do here, right?
Right.
So it's really about getting those definitions in. Okay, let me erase this and let me see if this table is correct. Yeah, this table I think just carried over from up here. Yeah, I don't think it goes with this at all. This is an error on my part. This is the same table in both locations, so that was just an error. Let me see if I can get another example of that, of graphing. Okay, there we go. All right, so as a reminder, right, we have our standard definition of a line here, or standard form of what a line is, y equals mx plus b, right? Your m is your slope, which is rise over run. Your b is your y-intercept. So it's where you should start with your first point. if you're graphing, okay? So we have this equation here, y equals 3x. What is my m and what is my b?
Your B is 0.
Perfect.
Your M is 3.
Perfect. Okay, so in this case, we don't have a fraction, right? We have a whole number. But what do we know about whole numbers? We can turn a whole number into a fraction just by putting a 1 under it. Okay, and that's what you'll need to do so that you have the rise over run, right? But you're going to start at 0 in this graph. So you're going to start at 0. That's going to be your first point. Where's your next point going to be?
3.
Nope,
Go
you have
up
to go
3.
up by 3, but then what do you do?
Over 1.
Over 1, okay? And then you do it again, right? Up by 3,
3 over
1. Okay, and now you can see that this is how your line is going to look. All right, I can draw it in. I cannot draw a straight line to save my life, but that's idea. Okay. All right. We're going to keep this information here in the middle. This information is super important to us. All right, so we're going to make sure we keep that. Let's take a look at this next one. Notice that this next one is not great, right? Because I'm looking for y by itself. So how do I get this y by itself? What do I need to do?
Move some numbers around.
Okay, which number am I going to move around? I actually only need to move one number around. I want the y by itself. What it's not by itself right now because of what?
Then the -5.
Good. So how do I get rid of that -5? What could I do?
Times it with something. Add it with something. The 2x.
I'm going to add it, right? To get rid of a -5, I need to do the opposite of what I see. So I'm going to add 5, right? But whatever I do to one side of an equal sign, I need to do to the other side of the equal sign to balance it out, okay? So if I need to get rid of this -5, I'm going to add 5. That's going to cancel it out over here on the right. And now I have 2x plus 5. So y is equal to 2x plus 5. I just moved that 5 to the other side, but I have to make sure that I know mathematically what I'm doing, right? And so to move this -5 to the other side, I have to add 5 to both sides. It's going to cancel it out here on the right and move it to the left, but I can just rearrange it. So now it's y is equal to 2x plus 5. All right, now that I have this format, which matches with the format that I need, right? The y is by itself. I can do what I need to do, which is to identify my slope and to identify my y-intercept. So what is my m?
2.
Good. What's my b?
5.
Okay, and remember, we're always going to turn all of our whole numbers into a fraction by putting it over 1, right? Because that's going to help us when we do our slope. So where am I going to start with this graph? Where's my first point going to be?
5.
Good. 5 on the y-axis, right? So I'm going to go up. So it's going to be right here. All right, where's my next point going to be?
2.
What do I do? From this 5, I do what?
Go up 2?
Yep, I go up by 2 and then
go over 1.
Over by 1, okay? So when I have this situation where it's not on my graph, I need to do the reverse, just so I can have a point that's actually on my graph that's accurate. So instead of going up by 2 and over to the right by 1, I'm going to go down by 2, 1, 2, and then over to the left by 1. You can see that all 3 of these points are still in the same path, right? They're not on some different path. And all I did was do the reverse of what I normally would do because I'm already at the edge of the graph, and it's not going to be easy for me to make that point work up here, right? I had to guess. I'm like, is this 2? I don't know, maybe. Okay, so what you can do is just do the reverse. So you go down by 2 and then to the left by 1. Down by 2 to the left by 1. Okay, and I have enough points now where I feel like I'm comfortable to make that graph. all right? But that is essentially how graphing works and why it's important to know your slope, okay? Sometimes you are not given the equation, you're just given the line, and you have to find the slope.
What do you mean, just the line?
Like this, for example.
Oh, okay.
Right? So you just have the line, and they're like, well, what's the equation? Or they'll ask you, what's the slope? So how do you figure that out? How do I find my slope? Well, there is a formula for that. And all of these formulas, I'm pretty sure, let me just double check real quick, are going to be on your formula sheet that you get to access. So it's not like you have to remember these. You just have to be familiar with how to use them. Let me double check. Yeah. So I'm just going to flash this real quick just so you know I'm not making it up. But this is your formula sheet, right, that you get to use on the GED test, right? This is the one that's going to be on a little link like in the upper right-hand corner. A lot of people ignore it. Right. A lot of people ignore it and they don't use it. They're like, I don't need this. I'm not going to ever need. Yeah, you always need it. For every single test, you're going to need that. You're going to need to access this link. Please don't forget it's there. And why it's important is because it keeps all of these things like, oh, look, here's that y equals mx plus b that I've been showing you for the last 15 minutes and using, right? We're also about to use this thing right here, how to find the slope. So I'm going to show you how to use this right here. People are like, well, I didn't remember what the slope formula was on the test. I'm like, you don't have to remember it because it's given to you in the formula sheet, okay? So that's why it's important. So you have to learn how to use them, but then also know that you can access them at any time. So we're about to use this formula right now, the slope of a line formula. Okay. So in order to use this formula, which is to find the slope, again, we always use m to signify slope. We have y2 minus y1 over x2 minus x1. Right? This is the official formula. Do not get caught up in these little subscripts. They don't mean anything really. Just make sure that you're subtracting y minus y and x minus x and in the same order. In order to be able to find the slope using this method, you have to be able to identify points on this graph. That means I'm not going to choose this point here because is it 1? Is it 1.5? Is it 1.25? I don't know. I'd be guessing, right? So you want to use a point that's very clearly defined. Like I know that this point is 4, 2. I can see that it clearly intersects at 4, 2. So that's the location of that point, right? Or I can use this point that's also very clearly -4, -2, right? And also don't shy away from using this point here in the middle. Well, I know that that is 0, 0. I have 3 points that I can use. It doesn't matter which 3 points I use, but which 2 of these 3 I use, but I just need to use 2 of them, right? I'm going to choose this one and this one. And so I have, make sure you put the y's over the x's. That's the important thing that also people forget. Remember, it's rise over run. So my m is going to be equal to 2, that's my first y, minus 0, that's my second y, over 4 minus 0. Okay, 2 minus 0 is going to give me 2. 4 minus 0 is going to give me 4. I can simplify 2 over 4 as just 1/2. So the slope of this line is 1/2. Is that true? Well, let me check. I'm going to use one of these points. I'm going to go up by 1 and over by 2. Yep, it works. Up by 1, over by 2. I should get on my next point, right? So you can always check your answers, but this, you can use the slope formula to help you find the slope when you're asked to find the equation of the line, or maybe to match it. And I think in this question asks you actually how to match the line to its equation. So if I know that 1/2 is my slope, all I would need is my y-intercept, like where this line touches the y-axis, it touches it as 0, to be able to put it into this formula for the equation of a line, right? I will replace the m with my slope and replace the b with my y-intercept. My y-intercept here is 0. My m is 1/2. So y equals 1/2 x is the equation for this line. So kind of like it all goes kind of full circle and reflects back on one another, right? So you have to understand the equation of a line to understand what the slope is, to understand what the intercept is, and how to use them all together to figure each other out, right? If you have one or two pieces, you can usually figure out the other parts. Okay. Hopefully that makes some sense.
Sort of.
Sort of. Yes. Okay. All right. I don't want to overwhelm you, and because especially because it's your first day, let's just go back to the main page and kind of reference this again. So take your time today and kind of like navigate around this site. And then when you get a chance before tomorrow evening, email me with the topic that you'd like Thursday's class to focus on.
Okay.
And then I will make sure that I am prepared and ready on Thursday to give you a lesson on that topic, so that you can leave there feeling more confident about what that topic is. All right.
Okay.
Yeah, because I'm just here to get you ready for this GED test, right? This is my job at this time, right? Is to focus in on just that. So what is it that you want? We can focus on that. We can do it. We can drill it. And then if we have time, we can even go over direct questions from past GED tests that focus on that topic, right? To kind of like,
Gotcha.
we got it. All right.
I'm going to go through some of these folders you have on here.
Okay. Good.
Some practice ones.
All right. Yeah. And just let me know what it is that you want to work on. And also like, if it starts at a point that's if something in the folder starts at a point that's too advanced for you, also let me know that like what comes right before this, right? You can also ask that question too, to be like, what is the topic that's immediately before this, so that I can, because I'm having like where it starts, it's too high, right? So
gotcha.
Just bring it down as well.
Okay.
Okay. All right, Jaleesa. So just let me know what I can help with.
I will. I'll be emailing you.
Okay, great. And I can I'll see you on Thursday.
All right. Thank you.
Yep, no problem. Have a good day.
You too.